In these video notes, we're going to look at how to calculate probabilities of compound events. So basically that just means the probability that multiple things happen together. We're going to start off by looking at how to make tree diagrams, and that's going to help us find the sample space, which is just the total number of outcomes all listed out. So for this birthday party, there are 3 events that I can choose from. So the first one is mini golf, then laser tag, and then roller skating. So I'm going to start off the first level of my tree diagram by listing off my 3 possible outcomes. All right, so now we have the first level of the tree diagram, which is the events. And then from each of those 3 events, we're going to list off the 3 possible times that we have, which are morning, afternoon, and evening. And so you can see I listed those off of the mini golf. I have those 3 options. I'm going to do the same thing by branching it off of laser tag, and the same thing branching it off of roller skating. And so now if I want to list out the sample space, I would just follow each path of my tree diagram and write down what it represents. So I could have mini golf in the morning, that would be this route. I could have mini golf in the afternoon, this route, or I could have mini golf in the evening, which would be this route. And then I can do the same for laser tag and roller skating. So laser tag in the morning, laser tag in the afternoon, and laser tag in the evening. And then last set, roller skating in the morning, roller skating in the afternoon, and roller skating in the evening. So each of these represents one possible outcome if I'm randomly selecting a time and activity for a birthday party. And so when I count those up, I can see that altogether I have a total of 9 outcomes. So when it asks for the sample space, that's listing off everything I did in black to show all the possible combinations. And then the number of outcomes would just be after I count all of those up. All right, next we're going to look at an example with randomly choosing thin or stuffed crust pizza and then a topping to go on that. So we'll still set up a tree diagram for this one. So our first options for the crust are either going to be thin crust or stuffed crust. And then once we've made that selection, we can choose between the 4 different types of toppings. And so the next level of branches, I would just list off my 4 toppings, pepperoni, veggie, Hawaiian, or sardines, and then I would do the exact same thing off of the stuffed crust, and that shows all of my possible combinations. So again, when I follow each branch, I can have thin crust pepperoni, thin crust veggie, thin crust Hawaiian, and thin crust sardines. And if I go with the stuffed crust, I can have stuffed pepperoni, stuffed veggie, stuffed Hawaiian, or stuffed with sardines. So altogether, I have a total of 8 outcomes. Now, there will definitely be times where it's not possible to draw a tree diagram. For these first 2 examples, we had pretty straightforward items, not a lot of items that we were listing, so it was easy to make a tree diagram. Sometimes you'll have much larger numbers or much more options, so a second way that you can find the number of outcomes is by looking at how many options there are for the first thing, how many options there are for the second thing, and then if I want to get to 8 outcomes, I'm just going to multiply those 2 numbers together. So that's called the fundamental counting principle, where you just multiply all of your different outcome numbers together to get that. And we can go back to our first example for a moment. We had 3 options for the events, 3 options for the times, and that gave a total of 9 outcomes, which matches what our tree diagram said. All right, so for this one, it just says how many different outfits can you make if you're randomly choosing from the things listed below. We will make a tree diagram with this just because we have 3 levels, but we'll also apply the fundamental counting principle so that you can see the shortcut. So the first thing that we're going to choose between is our shirts. So we can choose between a red shirt, a blue shirt, a white shirt, or a plaid shirt. Okay, and then the next set of branches will show our 3 different types of pants that we could have. And so off of each of the first branches, I'm also going to have options of jeans, sweats, or shorts. Okay, and then now that we have a third option, flip-flops or tennis shoes, we're going to extend our tree diagram even further and branch off of each of those 2 options. So now I can have a choice of flip-flops or tennis shoes from each of the outcomes that come above. This is where you might want to start abbreviating. If you do choose to abbreviate, you just need to make sure that you have a key off to the side to show what each of your letters represents, and then you don't want any of your letters to repeat. So if you have 2 things that start with S, you might want to use a different letter to represent that. Okay, that's a lot of flip-flops and tennis shoes. We can go ahead and count up all of those possible routes. So we could have red shirt, jeans with flip-flops, red shirt, jeans, tennis shoes, red shirt, sweats, flip-flops, red shirt, sweats, tennis shoes, red shirt, shorts, flip-flops, red shirt, shorts, tennis shoes. And then we can continue that all the way down, and every single complete branch is going to represent a possible outcome. If we were asked to write down what the sample space is, then we would need to list all of these outcomes. Okay, so then last couple choices, plaid shirt with jeans and flip-flops, plaid shirt, jeans, tennis shoes, plaid shirt, sweats, flip-flops, interesting combination, plaid shirt, sweats, tennis shoes, plaid with shorts and flip-flops, plaid with shorts and tennis shoes. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible routes along that tree diagram. So I can list off my 24 outcomes. And then if we compare that back with the fundamental counting principle, there were 4 options for shirts, there were 3 options for pants, and there were 2 options for shoes. So if I multiply 4 times 3, that's 12, and 12 times 2 gives the 24 that I expected based on the tree diagram. All right, now we're going to move off of tree diagrams and look at how to calculate probabilities. So this says you roll a number cube and then you flip a coin. We want to find the probability of rolling a number greater than 4 and then flipping tails. So for this one, it might be good to set up a table to show our total sample space. So we'll go ahead and fill that in now. And I'll be using a grid that is a 2 by 6. I chose 2 by 6 because that represents my possible outcomes. So over on the side here, I'll list the outcomes for the coin, which would either be heads or tails. And then along the top, I'm going to list all of my outcomes for the number cube. And since there are 6 sides, I have 6 possible outcomes. And now within the chart for my sample space, I'm going to list off all of those combinations. So I could flip a heads and then roll a 1, or a tails and then a 1, heads 2, tails 2, heads 3, tails 3, heads 4, tails 4, heads 5, tails 5, and heads 6, tail 6. So with this, I can see that there are a total of 12 combinations or 12 possible outcomes. And just like before, I can still use fundamental counting principle. 6 outcomes for the die multiplied by 2 outcomes for the coin is going to show that there should be 12 total outcomes. And then below, I listed those off in the sample space. Okay, so I'm going to circle everything that is a tail that's also greater than 4. So tails is the second row here. So tails 6 would work, tails 5 would work, but it says greater than a 4, so tails 4 would not work. So that shows that there are 2 out of 12 possible outcomes, which would simplify down to 1 out of 6. So the final probability would be 1 out of 6. A second way that I'm going to show how to get the 1 out of 6 that doesn't involve sketching a tree diagram or a chart is to use kind of a simple formula to represent getting to that number. So if I just look for probability of a number greater than 4, the probability of rolling a die and getting a number greater than 4 would be 2 out of 6, because that's either a 5 or a 6. Then the probability of flipping tails would be 1 out of 2. So I'm going to write down that number. And then just like with the fundamental counting principle, if I multiply these two numbers together, I'm going to get 2 out of 12, which is exactly what we saw before from the chart, which would then simplify back down to 1/6. So as you get a little bit more comfortable with this, you'll be able to skip some of the visual steps. Okay, next, you spin a spinner, and then you flip a coin. What's the probability of spinning red and then flipping heads? Just as far as some notation, I'm going to show you if you have a capital P and then put something in parentheses after it, I could say probability of red. That's how I could write what's the probability of getting red. And then I could also write probability of flipping heads. So if I write down what each of those individual probabilities would be, probability of spinning a red is 1 out of 4, and probability of flipping heads is 1 out of 2. If I want the probability that both of those things happen together, then I'm actually going to multiply those two values. So 1/4 multiplied by 1/2 is going to be 1 out of 8. And you could make a tree diagram to verify that, or you could also make a chart, just like we did in the problem before, except instead of doing the number cube across the top, you would do red, green, blue, and yellow across the top as your possible outcomes. Okay, next you spin a spinner, and then you roll a number cube. What's the probability of spinning blue, and then rolling an even number? So the probability of blue multiplied by the probability of even is going to give us the probability of blue and an even together. So just getting a little bit more mathematical, the probability of blue is going to be 1 out of 3. The probability of rolling an even number would be 3 out of 6, or 1/2. And so the probability that both of those things happen together would be 1 out of 6. And then just to tie that back with what we already know, I'm going to sketch out a really quick tree diagram. So our options will be 1, 2, 3, 4, 5, 6 for the number cube. And then we'll have our 3 different colors for the spinner. So that would look like this: blue, yellow, and green coming off of each of the possible numbers. And so if I want the probability of first getting blue and then getting an even number, that would be even down to blue, even down to blue, even down to blue. So looking at my tree diagram, there are a total of 18 outcomes. And I just emphasized 3 out of the 18. So 3 out of 18, if I divide by 3, would get me back to 1/6. And that's the exact same thing I got using the shortcut above. All right, and finally, you flip 3 pennies. What's the probability of flipping 2 heads and 1 tails? So this time I'll do one final tree diagram, but I'm going to go left to right instead of top to bottom. Doesn't matter which way you use, both are going to work equally as well. So I have 3 pennies. So when I flip the first penny, I can either get heads or tails. That's my sample space of just the first penny. Then once I flip that one, my options are either heads or tails again. So we'll add that to both of these. And then once I flip my third penny, my options are heads or tails again. So when I fill in the rest of it, I'm going to have all of these possible outcomes. So altogether, I have a total of 8 outcomes. And we want to follow what is the probability of getting 2 heads and 1 tail. So really quick off to the side, I'm going to list out what the sample space is, what our possible outcomes are. So we could have heads, 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 tails. Then we could have heads, tails, heads, heads, tails, tails. And then tails, heads, heads, tails, heads, tails, 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 heads, and finally tails, tails, tails. So there are my 8 outcomes, and we want to circle all the ones that have 2 heads and 1 tails. So that would be this one, this one, this one, and that's it. So that's going to be a total of 3 out of 8. And so for this one, because I'm not concerned with the order, I can have the heads, the 2 heads and 1 tail in any order. It's not going to work to use that shortcut because I want to have all the different combinations. So this is where a tree diagram would be really beneficial to get you to the 3/8. All right, there are your notes on finding probability of compound events, and thank you for watching.